In today's topic, we are going to see the advantages of LED. So this is the symbol of LED. This is anode, this is cathode, and the light is coming out of the LED. First advantage of LED, energy efficient. LEDs are now capable of outputting 135 lumens per watt. So it is highly energy efficient. Long lifetime. 50,000 hours or more if properly designed. So LED minimum you can get 50,000 hours. Third point, rugged, made of solid material with no filament, whereas in conventional bulbs and all we have filament or tube or bulb which may break. But when you drop an LED, nothing will happen. It is safe. So it is rugged. No warm up period. LEDs light instantly in nanosecond. Within nanoseconds, LED is on. So nanosecond is highly negligible time. Whereas for mercury vapor lamp, sodium vapor lamp, and tube light, conventional tube and all, you need some time to warm up and then only it will light. Not affected by cold temperatures. That is, LEDs start up even in sub-zero weather, even in minus 5 degrees, 10 degrees, or even 0, 5 degrees. For low weather conditions also, LED will give out light. That's a major advantage. Only at very high temperatures, it can give some problem. Third point, LEDs are directional. With LEDs, you can direct the light where you want it. So if you want to focus at a particular point, you can do very easily with LED. So the light power is not at all wasted in LEDs. Environmentally friendly. LEDs contain no mercury. This is very important because mercury is very harmful. LED does not contain no mercury or other hazardous substances. Therefore, it is user friendly as well as environment friendly. Whereas in conventional lamps, you can see mercury vapor lamps, sodium vapor lamps, you have some hazardous chemicals which is dangerous and it is not environment friendly. Next, controllable. LEDs can be controlled for brightness and color. So you can control the brightness of the LED by using an external control circuit or a variable resistance through which you can control the brightness of the LED, or you can do pulse width modulation in advanced topics like pulse width modulation kind of brightness control also can be done. Okay, this is controllable. Then is main disadvantage is blue hazard. There is a concern that blue LEDs are cool and cool white LEDs are now capable of exceeding safe limit. So if you see the VIBGYOR range, violet, indigo, blue, it can lower than the blue wavelength, it is not safe. That is, blue LEDs can emit water, hazardous wavelengths. So it will exceed, sometimes it may exceed the safe limits. That is there. Now okay. Now we have what is the forward voltage for an LED to operate. So color, voltage drop at 20 milliamps, semiconductor material used. For a red LED, the forward voltage drop is 1.8 volts at 20 milliamps. The material used for making red LED is gallium aluminum arsenide. For orange, the forward voltage is 2 volts and the semiconductor material used gallium arsenide phosphide. For yellow, the forward voltage drop is 2.3 volts and the material used is gallium arsenide phosphide. For green, the forward voltage drop is 3.5 volts and the semiconductor material used is indium gallium nitride. For blue, the forward voltage drop is 3.6 volts at 20 milliamps and the semiconductor material used is indium gallium nitride. For white, the forward voltage drop is 4 volts and the material, semiconductor material is indium gallium nitride. Okay. Now we will see one design example. I want to use a white LED. Okay. The white LED, the voltage drop is 4 volt. Okay. This is we know. If you the voltage across this anode and cathode, if it is 4 volts only, then it will give off light. And we have seen just now, we have seen the data sheet, the required current is 20 milliamps. So this is the current flowing through the white LED. We have taken white LED as the example. Now assume the input voltage is 10 volts, that is with respect to ground this point is at 10 volts. With respect to ground this point should be at 4 volts. So 10 minus 4, the voltage drop across the resistor is 6 volts. Now I have to find the value of R. We know the current as 20 milliamps. So R is equal to V by I. So voltage drop across the resistance is 6 divided by 20 milliamps. So that will give you 6 into milli goes numerator 1000 divided by 20. If you solve for it, you will get 300 ohms. That means if you connect 300 ohms and if you give a supply of 10 volts, then this white LED will be drawing a current of 20 milliohms and the forward voltage will be 4 volts. Therefore, the white LED will give off white light. So this is a small design example. So for different color LEDs, the forward voltage drop is different. It is not same. If you see silicon diode, the forward voltage drop is 0.6, germanium 0.3. Whereas for LEDs, for different colors, the forward voltage drop is different. And also if you see the semiconductor material used, the last 3 cases it is same indium gallium nitride, but there is small variation in these green, blue and white. And for these things gallium arsenide phosphide, and for red it is gallium aluminum arsenide. For very long time blue was not invented, others were there. With the invention of blue LED, there is a big dramatic change in the optical electronics, especially in the lighting and communicating. One more advantage of LED is, even if we have a LED for room lighting, we can send information through these wires and we can communicate through LED and a photodiode. That means the same wiring setup can be used for communication. So LEDs can be used for communication through wires. That is one way. Or we can have point-to-point communication. That means you mount a LED here in a tower, you mount a LED. So here you will be having an LED. Okay, this is will be sending out light, and at the distance you keep one photodiode and this will be receiving this information. So this distance can be specified. If you use a laser kind of LED, then you can have point-to-point communication and there should not be any difference. Maybe for half a kilometer and all, it's half a kilometer to 1 kilometer. With a laser kind of LED, we can easily communicate data from one point to the other. So here we have a laser source and here we can have a photodiode array, so that this LED source will strike any one of the photodiode. Similarly, from this end you must have one LED, and this side you must have a photodiode array, so that the light coming from this side is received by the this side. That means two-way communication is possible using LEDs, provided there is no disturbance between the transmitter and the receiver. So that is one great advantage of LEDs. And LED can be easily switched on and off any number of times. Nothing will happen to the LED. Whereas for the ordinary bulb and all, sodium vapor lamp, and if you frequently switch on and off, the filament get spoiled and it may be open circuit. That's a big issue in sodium vapor lamps, mercury vapor lamps and CFL, compact fluorescent lamps. So these, if you frequency switch on and off, the bulbs will go off. So these are some drawbacks with the conventional bulb arrangements like sodium vapor lamp, mercury and CFL, okay, compact fluorescent lamp. Whereas for LEDs, nothing will happen. You can have switching in nanometer in a very high way. You can switch it even at 1 megahertz, 10 megahertz, nothing will happen to the LED. So that's all about the basic things you should know about LED, its advantages, its disadvantages in the blue range, and how to design a LED for a simple applications. So thank you for your attention. Thank you. Nandri.